Hello, welcome to the Week 9 review for Andromeda. So we've been working on a branch this week, um, refactoring some of the wallet code, and then creating an interface between the wallet code and the machine learning backend to perform automated trading. Um, so, let's see. Refactoring the wallet code. So I broke some things out into individual functions. Calculate total worth was already there. One of our team members had written that. I added deposit, which will just add an amount to a cryptocurrency pair that you already have. Then update the database. Buy will take a user info, which is this data structure here. Whoa. So this data structure here, it will take this entire object as the user info. And in that data structure, you've got an object of cryptocurrencies, an array of trades, an array of holdings, which I have none, and then cash out. I think I need to fix that because it didn't quite work right. Oh, no, I need to refresh the data. There we go. Okay. Yeah, so there we go. Cash out. We got an array of trades, which is very long. An array of holdings. That's still a little messed up. I think I need to fix that for the branch. So that's implemented on master, but I don't think I pulled that into my branch yet. And that one also is not in the branch. So this used to be an array. It refactored into an object where the keys are the type of coin and the value is the value that you have of that balance. So that will go right into here. The trade pair is what you're buying, the amount is how much, and the epoch is used for back testing. You use 0 for the current time, which will be the normal use case, or if you're back testing a data set, you can iterate through epoch frames and provide the timestamp manually. And the same for sell. Right here, same parameters, user info, trade pair, and amount. And that will sell that particular coin back into Bitcoin. Whereas buy will take from your Bitcoin balance and buy that particular type of coin. And then I took the trade function, which was already implemented, and then I just used that as a wrapper for buy and sell. So we will run a back testing simulation, which will erase the wallet. So resetting user wallet, and then depositing 5 bitcoins from address ... and then now it's off and running. So it runs for 24 hours of data, and let's see, it will run. So start epoch is the current. No, wait. Okay, yeah. So end epoch is the current one that we're in right now. And then the start one is 288 epochs ago. So 288 times 5 minutes divided by 60 minutes per hour, 24 hours. So that'll run for 24 hours of data. And we're skipping every... we're only trading every 4th epoch, and so this number right here will eventually get refactored into something we're working on for the final release, where you can have a user parameter to specify how quickly you're performing trades. So that's off and running. I'll pause it so we can wait till the final result comes in. Okay, so we're back. That was about 5 minutes of waiting. We're at about 87% of completion for generating like historical data results. So this is good, for back testing the model, make sure it works right. Unfortunately, the model isn't quite as smart as we wanted it to be. It does trade, and makes a margin off of that. It's just it's not good enough. If we were to use something like a multi-layered deep network, um, then it would probably get better results. Right now, we only have one layer of nodes, and so those don't feed into anything else for calculating the score of a coin. Um, so we have to kind of trade in the middle of the data set and not kind of push those extremes where you could capture some high volatility. So we're done now. We went from 5 to 5.27 with a total return of 5.4%, which over the course of 24 hours is pretty fantastical. If I could make 5.4% daily on something, I'd be jumping up and down. The problem is to test this model and to see if it even worked at all. I had to zero out the fees. Normally there's a 0.2% fee for every transaction. So with the amount of trades we're doing, we'll just take a quick look here, and then we'll wrap this up. Refresh the data. All right, trades. Okay, 1391, and we expected. We had 288 epochs divided by 4. So we're only trading every 4th epoch, and then we're trading 10. Oh, times 2, right. So we're buying and selling every coin every time. So 1440. And there are some coins that I have to flag as like invalid because they start with a $sign, and I can't use a $sign as a key in a MongoDB. I was working on some string replacements to replace $signs with underscores, but I was like, no, I don't. I don't want to add that kind of complexity right now and break everything. So if it's a $sign, like dollar, or there's a couple other ones that are like dollar fast or whatever, I just ignore that trade. So we lose a couple trades out of there. So 1440 is the target, and we came in 1391. So if we were losing 0.2% over almost 1,400 trades, any margin we made would be gone, and then also our balance would be gone. So not good for a realistic trading model, but for a simulation where we're testing a machine learning environment, it went up. So the cost function did minimize, and we made some progress towards what we wanted. So the last couple days here, home stretch, we're going to work on final check-ins, integration of all the components to make sure they work right, and then deployment to the server, and then final report. Thanks. Bye.